This is a tutorial to look at how we can work out the impulse associated with vertical ground reaction forces during a running footfall. The tutorial was designed to complement the work covered in the workshops on the second year biomechanics course. Okay, let's have a look at this particular problem. On the screen at the moment is a representation of three instances during a running footfall. It has to be stressed that these are just a sample of instances, and obviously there could be many more particular positions adopted by the runner during the footfall. So these are just a sample. Now, you should know from the workshop material, and indeed from the work that you covered in the first year, that when the runner's foot makes contact with the ground, that it will elicit a ground reaction force, and we can represent that ground reaction force as a vector arrow. So on this diagram you actually see, for the three sample positions, a ground reaction force acting, and this is obviously in accordance with Newton's third law. Now, remembering that this tutorial is focusing on the vertical ground reaction force, if we're to understand how this particular set of forces affects the runner, we need to be able to consider not just the resultant ground reaction force, but actually the components. Again, if you reflect back on your first year work, you'll know that you can take a resultant and you can change its characteristics by looking at the components. So on the screen at the moment we've got representations of the resultant vectors that we saw in the previous diagram, but actually we only need to know information about the vertical components. And so what we're going to do here is we're going to actually remove the components that we don't need. So in this particular case we've got a vertical component for the first position now on its own, a vertical component for the second position. And notice that in the second position actually there only ever was a vertical component, because in the mid stance position there wasn't actually a horizontal component. And then finally in the third position we just need to remove the resultant and the horizontal component. So